This is a GCSE chemistry tutorial in topic 9, focusing on global warming and pollution. In this tutorial, we will look over global warming and the greenhouse effect, and what it means to be a greenhouse gas. We will also look at carbon footprints, particulates, and the effect of acid rain. Our questions for today's tutorial are to state what is meant by the greenhouse effect, to describe how a carbon footprint could be reduced, and to explain the dangers of a variety of products formed in the combustion of fossil fuels. And our big question is to explain the effect that an increase in greenhouse gas emissions would have on climate change. So what are greenhouse gases? Well, simply, greenhouse gases are gases that cause the Earth's atmosphere to heat up. They do this by increasing the insulation that the atmosphere provides to the Earth. The gases included in the greenhouse gases are gases like carbon dioxide, methane, CH4, and water vapour. So how do greenhouse gases work? Well, greenhouse gases work by absorbing a particular wavelength of radiation from the sun. To start off with, they don't absorb the incoming short-length wavelength. Therefore, this short wavelength radiation from the sun goes through the atmosphere and hits the surface of the Earth. Some of this wavelength is absorbed by the Earth, but a large amount of it is reflected back off of the surface. This radiation then is reflected off of the Earth back through the atmosphere. Some of this gets released back into space. This is the short wavelength radiation, as the greenhouse gases do not absorb this. However, the long wavelength radiation gets absorbed and then reflected back down towards the Earth, being re-radiated and therefore warming up the surface. This long wavelength radiation is thermal radiation. So by reflecting it back down to the Earth, this will warm up the surface. This reflection can then happen multiple times. This entire process is known as the greenhouse effect. The greenhouse effect is a naturally occurring process. However, human impact is affecting it. As human activity releases more greenhouse gases, the amount of the greenhouse effect increases. Therefore, the surface temperature will also increase. Human impact can be put into 4 different categories. The first is deforestation. This is where trees are cut down, usually to make way for farming. Fewer trees means less CO2 is removed from the atmosphere via photosynthesis. Therefore, there is more CO2 present in the atmosphere, increasing the greenhouse effect. The second method of human impact is the burning of fossil fuels, or the combustion of fossil fuels. As fossil fuels contain locked up carbon, this is released as they are burnt, releasing it as carbon dioxide, once again increasing the greenhouse effect. The third method is in agriculture. More farm animals means there is more methane being released through the digestive processes that farm animals use. By increasing the amount of methane, this is also increasing a different greenhouse gas. Therefore, we can once again link this to an increase in the greenhouse effect. It's important to note that most agriculture will need land, therefore more deforestation takes place, forming a double hit of increase to the greenhouse effect. Finally, we have creating waste. As a species, we produce a lot of waste, a large amount of which goes into landfill sites. Landfill sites, including the waste from agriculture, means there's more CO2 and methane being released as the waste decomposes. This decomposition is carried out by microorganisms. Once again, increasing CO2 and methane will increase the greenhouse effect. CO2 emissions, that's the CO2 being given off, has increased over recent years. We've got here a graph showing 1880 to just about the year 2000. And we can see an overall trend in an increase in the amount of carbon dioxide, as well as an overall increase in the average global temperature. It is important to note that climate change and the greenhouse effect and global warming are all naturally occurring events. However, most scientists agree that the extra carbon dioxide from human activity is causing this increase, or at least causing the increase to happen faster. Evidence for this has been peer-reviewed, so it has been checked by multiple scientists. However, it is important to note that there is speculation, particularly in the media, where stories have been biased or only some of the information given. So the information out there on global warming isn't necessarily 100% accurate. An increase in the Earth's average temperature could have dangerous effects. An increase in global temperature could lead to the polar ice caps melting, which could cause flooding and coastal erosion. Changes in rainfall patterns could cause droughts or more flooding again, leading to differences in the amount of food that is available. The frequency and severity of storms may also increase. And finally, drastic changes in temperature or the amount of water available in a habitat could affect many species, potentially resulting in extinctions. Lots of work is being done in order to reduce the amount of greenhouse gases that are being emitted from human activities. In order to do so, we need to look at carbon footprints. So what is a carbon footprint? Well, a carbon footprint is basically a measure of the amount of carbon dioxide and other greenhouse gases released over the full life cycle of something. This could be a service, for example, the amount of greenhouse gases released by an aeroplane. It could be an event, for example, the World Cup, or it could be a product. It could also be over someone's life or an animal's life. However, measuring the total carbon footprint of something can be really hard, or in some cases, basically impossible. This is because we have to think about all of the different factors of a life cycle. So the emissions released when making the product, when using the product, or when disposing of it. This links in nicely to life cycle assessment, which we will look at in a future video. We can, however, give a rough calculation of an idea of what the worst emitters would be, so people can avoid them in the future. So how could we reduce the carbon footprint? The first method we could use is to ensure we're using renewable energy or nuclear energy. This is because neither renewable energy or nuclear energy releases greenhouse gases. Therefore, they have a much lower carbon footprint than using fossil fuels. We could also ensure that we are recycling. Recycling will cut down the amount of waste that's decomposing and therefore producing methane, and therefore this would also reduce carbon footprint. This also links into using more efficient processes so we can try to conserve energy and therefore cut waste. We could also further tax both companies and individual people, increasing the level of tax paid for the amount of greenhouse gases that are emitted. This has already been done in London in the low emission zone, where you have to pay the emission charge in order to go into that area, with the amount that you pay changing depending on the efficiency of your vehicle. We could also try to set limits on how much carbon dioxide can be released by a car, and therefore only in the future sell cars that are below this new guideline, otherwise they will incur a very heavy tax. We could also try to cap the amount of greenhouse gases that are being released, so setting an upper limit for greenhouse gas emissions. Any companies that break this would then face severe fines. This would also allow companies to sell part of their allowance in order for the emissions cap to still be met. Finally, we can use new technology. There is lots of types of new technology that can capture CO2 when it is produced from burning fossil fuels. We can then store it underground, for example, in old oil wells that have been depleted. However, making reductions is still difficult. There's a difference between saying we should cut emissions and actually doing it. For a start, we need to do a lot of work on alternative technologies. Also, in the West, our society is based around using fossil fuels, so it is a huge change to go over to more renewable methods. We also need to get international agreements, such as the Paris Agreement. But perhaps most importantly, it's not just governments, it's individuals in developed countries that need to make changes to their lifestyles. The final topic within topic 9 looks at air pollution. These are known as pollutants. So carbon dioxide isn't the only chemical released when fossil fuels are burnt. We can also release 3 other dangerous chemicals as well. These are nitrogen oxides, such as NO and NO2, sulfur dioxide, SO2, and carbon monoxide, CO. We will also look at the release of particulates, such as soot, which are just carbon. These 3 chemicals are dangerous in different ways to both the environment as well as to us. When anything is burnt in oxygen, it's said to have been combusted. This is true for fossil fuels. In this, the carbon and hydrogen found in the fossil fuels are oxidized. This produces carbon dioxide and water vapour. Both of these are then released to the atmosphere. When there is lots of oxygen available, the reaction is clean burning and is known as complete combustion. Complete combustion happens when there is plenty of oxygen. In this, we only produce carbon dioxide and water vapour. The reaction is the hydrocarbon, in this case the fossil fuel, plus oxygen goes to carbon dioxide and water. A balanced equation would be as follows. CH4, which is methane, plus 2O2 goes to CO2 and 2H2O. However, sometimes there is not enough oxygen for complete combustion to occur. When this happens, this is known as incomplete combustion. In this, we get particulates and carbon monoxide being released. Which one we get depends on the amount of oxygen that is present. First of all, if there is less oxygen than we need, we get the formation of carbon instead of carbon dioxide. We still produce the water vapour. So our equation would be our hydrocarbon, in this case our fossil fuel, plus less oxygen goes to carbon and water. This carbon is our particulate and is known as soot. Our balanced equation would be CH4, methane, our example of a hydrocarbon fuel, plus O2 goes to C and 2H2O. In limited oxygen, we do not get the production of carbon. Instead, we get the production of carbon monoxide. So hydrocarbon, which is our fuel, plus our limited oxygen, forms carbon monoxide and water. In this case, our balanced equation is CH4, methane, our carbon fuel, plus 3O, so instead of O2, we've now just got 3O, goes to CO, carbon monoxide, and 2H2O. We will now look at the problems that these products form. The particulates, those bits of soot, that carbon, can have problems to us for breathing as well as to the environment. For us, the major problem is that it can cause respiratory problems or even potentially respiratory failure. The particles enter through the mouth and get stuck in the lungs. Particulates can also cause problems for the environment. First of all, they can coat buildings, making them darker, but more importantly, they can cause more sunlight to be reflected back into space by getting in the way and reflecting the light. This means that less light reaches the Earth's surface, and this is known as global dimming. Carbon monoxide, on the other hand, is a particularly nasty product. Carbon monoxide is a tasteless, senseless, and odourless gas. As such, we can't see, smell, or hear it, but it can be stopped with a detector. It's particularly dangerous because it prevents your hemoglobin from carrying oxygen around your body. This is because carbon monoxide binds to the hemoglobin in place of the oxygen. This lack of oxygen in your blood can lead to fainting, putting you into a coma, or even in high quantities causing death. Carbon dioxide, carbon particulates, and carbon monoxide are not the only products formed when fossil fuels burn. Sulfur is found in lots of fossil fuels such as coal. When this is combusted, burnt in oxygen, it forms sulfur dioxide. Sulfur dioxide is a poisonous gas, but more importantly, it can dissolve into water vapour in the atmosphere to produce sulfuric acid. This then falls to Earth as acid rain. Acid rain can cause respiratory problems for us when we breathe it in, and it can also cause burns. Importantly, it's very, very dangerous to the environment, as we will look at in a couple of slides' time. Another byproduct is nitrogen oxides. This happens because when any fossil fuel is combusted, it produces a large amount of heat. This heat is enough to cause the nitrogen and oxygen in the air to react. Remembering back to the previous video where 78% of the atmosphere is nitrogen and 21% is oxygen. Just as we saw with sulfur dioxide, nitrogen oxides, mainly NO and NO2, easily dissolve into water vapour to form an acid. Instead of sulfuric acid, this is nitric acid. Once again, this can fall to Earth as acid rain. Both the nitrogen oxides and sulfur dioxide can cause respiratory problems and in high concentrations can be lethal. However, the damage to the environment is caused by acid rain. Acid rain is rainwater that is either sulfur dioxide or nitrogen oxides dissolved into it. This is either known as sulfuric or nitric acid, dependent on which one is dissolved. Acid rain can cause huge damage to plants, buildings, and statues. It can also cause huge amounts of devastation to lakes, and as we can see, can strip entire forests. This concludes topic 9, where we have looked at the atmosphere and how it has changed from the past to today, how it continues to change with global warming, our carbon footprint, and air pollution.